Hey guys, just doing another video. This one is on the idea of adding additional constraints. We must remember that by definition lines are infinitely long. So this poses a problem when we graph scenarios because it will suggest impossible situations. So we're going to go with the same scenario as last time. Bride and Luong owning a grocery, buying pineapples for $2 each and watermelons for $3 each, and can spend up to $30 on pineapples and watermelons. So we're going less than or equal to. He can spend 30 and he can spend less than 30. When I draw that region, strictly speaking, we have this. Okay, so this region that I've colored in grey is 2x plus 3y is less than 30. The line represents the equal to 30. So what I've represented on this Cartesian plane is the region 2x plus 3y is less than or equal to 30, okay? This indicates that Bryden could buy 3 pineapples and 8 watermelons. That point is on the line for, what would that be? 3 times 2 is 6. 6 and 8 times 3, 24. That would be $30. We could go with a point within the region. He could buy 11 pineapples and 1 watermelon. What would the result of that be? 11 times 2 is 22 plus 1 watermelon. $325. Spending $25 there, which is okay because he could spend up to and including $30. Bryden could buy -7 pineapples and -1 watermelons. Because we're talking maths here. That region goes on forever. This line goes on forever. That region goes on forever down and to the left. So if we're strictly speaking mathematics-wise, -7 is times by 2 is -14 plus -3, $17. Does that seem reasonable? The idea is no. Clearly the last option is unreasonable. To avoid this, we need to add additional constraints to this scenario. We need to lock it down. We need to close it up. Close it up from the unrealistic situation, which is basically negative numbers. In realistic scenarios, you will need additional constraints to prevent the x and y variables being negative. So, constraint of x is greater than or equal to 0 will form a vertical line along the y-axis. Why? Because the value of x along the y-axis is 0. So that constraint x is greater than or equal to 0 will form a vertical line, meaning the x variable may not be negative. So that constraint would look like a line that just goes forever up and down like that along the y-axis. The constraint y is greater than or equal to 0 will form a horizontal line along the x-axis, meaning the y variable may not be negative. So that constraint would be a line infinitely going along the x-axis, which stops you from having y variables that go down here. You can consider these two default constraints for any scenario involving things that have to exist. These default constraints can be overridden by other constraints in the question though, so read carefully. So unless the question says otherwise, right? If the question involves things that should exist, these constraints will be there by default. They don't have to be stated because you can't have -1 pineapples, -2 watermelons, okay? What I'm saying here is sometimes the question will override that because it will need a certain number of the x and y, okay? So these additional constraints mean the region of feasible solutions will now be enclosed, avoiding impossible situations. An enclosed region of feasible solutions is known as a simplex, and the corners of the simplex where multiple constraints meet are known as vertices, vertex for singular. When you draw these in questions that involve drawing a simplex, you must always label the line equations drawn, label the vertices and shade the simplex. So if I was asked to draw this scenario, I would draw these constraints by default. Label that, that's x is equal to 0. Another constraint here, that line is y is equal to 0. So now my coloring will not extend beyond the axes. There won't be anything unrealistic. It's locked in. And you'll see that I labeled the, oh, I went outside. Uh-oh. Obviously, when you're answering one of these questions, you'd do this more carefully. I'm just doing it very quickly for the video. And I need to label the vertices, which is 15, 0. This one is 0, 0, because it's reasonable for you to buy no pineapples and no watermelons. And then this one is 0, 10. That is more like what you would be doing in a proper question, okay? Now let's do a more complex scenario. Let's continue with Bryden. I'll stop hammering this soon. Bryden Luong owns a grocery, buys pineapples for $2 each, watermelons for $3. Bryden has up to $30 to spend on pineapples and watermelons. Bryden must have at least 3 pineapples and must have at least 2 watermelons. Graph the simplex for what Bryden can buy. So we've been hammering this situation with the purchases. It was 2x plus 3y is less than or equal to 30 is the first constraint. But we have additional constraints that say we must have at least 3 pineapples and at least 2 watermelons. And this is a scenario where it's overriding the default of x is greater than 0 and y is greater than 0, because now we're saying that x must be greater than or equal to 3 and y must be greater than or equal to 2. So here, x greater than or equal to 3. Oh. Y greater than or equal to 2. Can I draw those lines now? Well, I'm going to draw the line of 2x plus 3y is equal to 10, and then I'm going to shade that region there. So 2x, 30 divided by 2 is 15, and then 30 divided by 3 is 10. So that first constraint goes from 10 on the y-axis down to 15 on the x-axis. Label the line 2x plus 3y equals 30 is the line that I just drew. The constraint for pineapples is x is greater than or equal to 3, so I need to draw the line of x is equal to 3, which is a vertical line at x is equal to 3. Watermelons, y is greater than or equal to 2, so I need to draw the horizontal line where y equals 2. It's along there. Label that 2. Y equals 2. So the region enclosed by all 3 of these constraints, less than or equal to, means down and to the left. So I'm going to be coloring down that way. X is greater than or equal to 3. Greater than or equal to means to the right and up. So I'm going to be coloring in that direction. And this horizontal line, greater than or equal to 2, so I'm going to be coloring up or to the right. So I'm going to be coloring there. So the only region that follows that is this triangle here. That is the simplex, representing the feasible region of solutions for this problem of Bryden buying watermelons for $2 each. Pineapples for $2 each, watermelons for $3, having up to $30 to spend, but he needs to have at least 3 pineapples and at least 2 watermelons. Not quite done yet. I need to indicate the vertices, so that is 3, 8. This is 3, 2, and this is 12, 2. That is how you draw a simplex at this level of expectation. Okay? Hopefully that helps you out. I'll see you on the next video.